This is section 3.2 where we're going to introduce to you what's called synthetic division. Before I do this, I'd like to talk about long division and the process that you might have used back in maybe, let's say, third grade. And so we know that the very first step we're going to do is divide. You would have asked yourself in third grade, how many times does 3 go into 7? That's the same thing as saying, what is 7 divided by 3? And we're going to say that that is 2. So the very first step is to divide. The second step is we're going to multiply. So we're going to take that 2, we're going to multiply by the 3, and we're going to get 6. The third step is that you will subtract that 6, and you'll get 1. And then the next step is that after you subtract and get 1, you're going to bring down that 4. So bring down is going to be your fourth step. And then you're just going to repeat or find the remainder. So we would ask, how many times does 3 go into 14? Or what is 14 divided by 3? That's going to be 4. 4 times 3 is 12. We're going to subtract. And we'll have a remainder of 2. Now, there's a couple of ways that we can write this. But one of the things is that we can always check our work. So we can say that our dividend, which is 74, is going to equal our divisor, which was 3, times our quotient, which is 24. And we're going to add our remainder to that, which is plus 2. Now remember, back in third grade, you could have written this, your quotient, as a 24 remainder 2. Or you could have said that this is 24 and 2/3. And I'm going to bring your attention to that here in just a bit. All right, now let's talk about synthetic division. Synthetic division, first of all, make sure that in order to avoid any errors, that you use a 0 for missing terms, even a missing constant when you're setting up your division. All right, so the first thing that you're going to do, and I have a little graphic over here that you can follow as well to help you out with this. But the first thing that you're going to do is you're just going to pull all of your coefficients down. All of your coefficients, make sure that if there's a missing coefficient, a missing term, that you replace it with 0. In this case, there is not. When I'm dividing, I am dividing by x minus 3. But over here out to the left, you're always going to put what x equals. So if you were to solve x minus 3 for x, then x would equal a positive 3. And the very first thing that you'll do is you're going to simply bring down that 4. No math there, just bring it straight down. And then you're going to start this process of multiplying and adding over and over and over again. So you're going to take the number that's down here, you're going to multiply by what's up here. So that's going to give you a 12. And then you're going to add that 12 to whatever is above it. So a negative 15 plus a 12 will give you a negative 3. And then you're going to repeat this process. So multiply, negative 3 times 3. And then add that to whatever is above, which is going to be a 2. Multiply, 2 times 3, it's going to be 6. Add it to what is above, and that's going to give you a negative 4. Now, this doesn't look a whole lot like division, but what you want to understand is that this number back here, this is going to be our remainder. These numbers up here are going to lead us to the quotient. And the way that I get the quotient is that the first number before the bar is going to be my constant. This is going to be my x to the first. This is going to be my x squared. And any terms before that are going to keep on walking their way up. So x cubed, x to the fourth, etc., etc. So my quotient here is going to be 4x squared minus 3x plus 2. My remainder is going to be a negative 4. The way that I'm going to write this as an answer is going to be the quotient, 4x squared minus 3x plus 2, plus my remainder over my divisor. And remember that my divisor came from this number right up here. All right, so that's, and it says plus, I said plus, but this is, remember, a plus negative 4. So that's why it says minus there. One of the things that we can always do is we can always rewrite our polynomials using this same concept back here, the way to check your work, where I have that the dividend is equal to the divisor times the quotient plus the remainder. I can always do that as well. So in this particular case, I would have, let me zoom out a little bit so I can see it. I would have here 4x cubed minus 15x squared plus 11x minus 10. That's my f of x, is going to equal my divisor, which was my x minus 3, times my quotient, which was 4x squared minus 3x plus 2, and then I'm going to add my remainder, which was a negative 4. All right, so I can always change this into a multiplying question after I've divided. Okay, the remainder theorem, if you have a polynomial, and you are dividing that polynomial by x minus k, then the remainder is going to be f of k. All right, now let's put that into practice. So in example 2, we've been given f of x, and we are told to find f of 4. Now, up until today, you would have said, well, let me just plug and chug. But we can use the remainder theorem to do this. So the first thing that we're going to do, just like we did in the last example, we're going to get our coefficients. Notice that I've put a 0 placeholder in for the x squared term. And then out in front, remember, it's whatever my x value equals. So out in front, my x value is equal to 4. So the first thing that you want to do is you just want to bring that negative 3 straight down. And then you're going to multiply by what's out front. Add, and you'll get 3, then multiply, you get 12. Add, you get 12. Multiply, you get 48. Add, you get negative 2. Multiply, you get negative 8. And then add, and you get 17. Now, this was, it is exactly like the division question we just did in example 1. The difference is that I'm asked to find f of 4. And we know that even before today, if we find f of 4, that's just going to be a plain old number. So my answer to this is not a quotient and a remainder. My answer to this is just simply that f of 4 is equal to 17. All right, let's look for some potential zeros. So a 0 of a polynomial is going to be a number k such that f of k is equal to 0. Real number zeros are the x-intercepts, are the x values of the x-intercepts of the graph. Some more names, you could call it a root or a solution of the equation f of x equals 0. And I want to highlight for you just a few words that we used here. We used the word 0, we used the word x-intercept, we used the word root, and we used the word solution. All 4 of these mean the same thing. Please be familiar with all 4 of those titles, all 4 of those terminologies. All right, looking at example 3, part A. And determine whether the given number is a 0. Going back to what we just said here, remember that in 3rd grade you got really excited when your remainder was 0 because it went in evenly. And we're going to get excited about the same thing here. When our remainder is a 0, then what we have found is an x-intercept. We have found a 0. We have found a root. We have found a solution. So for here, when it says to determine whether k is a 0, k is our value of 2. Let's go ahead and use synthetic. So we'll go ahead and get our coefficients. Notice outside. Now, you'll notice that I did change my formatting just a little bit here. The way that I wrote them up here, this is the way that my lab does it. And then this down here is a little bit more common. So they mean the exact same thing. So the first thing you want to do is just to bring your 2 straight down. And I'm just going to go ahead and go through this pretty quickly. If I were you, I would pause the video and see if you get the same thing that I do at the end. All right, so again, we're multiplying and adding, and I find that my remainder is negative 14. So is 2 a 0 of my polynomial? No, it's not. It is not. For part B, we'll do the exact same thing. So we'll bring our 1 down and start our process of multiply, add, multiply, add, multiply, add. Again, pause the video, see if you get the same thing. And we end up here with 0 remainder. So in this case, the value of -3 is a solution to my polynomial. It's an x-intercept, it's a root, it's a 0. Now for part C, this one's a little more challenging because now I'm being asked about this complex number. Is it a 0 of my polynomial? But we're going to work it the exact same way. And so I spread my coefficients out a little bit more. I need more room on this one. So the first thing I'm going to do is bring down my 1 and multiply by the box. So when I add, just combine like terms, and I'm going to get a 3i. When I multiply 3i, you can see that I showed my work over here. When I multiplied my 3i by the box, I got -9 plus 3i. Add to what's above it. I have -3 plus 3i. So once again, you can see over here, I've got some work to show this. -3 plus 3i times the box gives me -12 minus 6i. Combine like terms. And I'll get 2 minus 6i. Go to the right to see my work for the multiplying. I get a positive 20. My remainder is 0, so yes, 1 plus 3i is a 0 for this particular question. So what is the process then for determining whether a number is a 0? What we need to do is just find out whether or not the remainder is 0. If my remainder is 0, then I have a 0. I have a root. I have a solution. I have an x-intercept.